right. How's everyone feeling? Good? I'm the last thing between you and a pile of beer, so I'm going to try and make this fast. I have 15 minutes and I have 60 slides, so this is going to be a real fun one. But I'm going to talk about a bunch of different things. I'm going to talk about Python, PyData, the open source community that we've built around all of that, what we've learned from it, the nature of open source software, AI, and how we can think about all of that. So it's a whole bunch of different things. And I'm going to, actually, I had an agenda slide, right. A lot of topics which many people have talked about, and some of the other keynote speakers have touched on as well. So let's get right into it. So why Python? That's a question I get asked a lot, sometimes in a very positive, curious way, and sometimes in a very antagonistic way. Why did you do this to us? Why did you make everyone use Python? So the story really is very simple, and it's that 12 years ago, my co-founder and I, we had a vision that we could take the scientific computing tools that were very popular in Python. They were starting to become more and more popular. And we could apply them to general data analytics and to business computing. And this was the time when the term data science was just starting to come around. Big data was really the main kind of buzzword term at the time. But we sort of realized that once you had big data, you were going to start asking questions of that big, messy data. And Excel and SQL were not going to be enough. So you need tools like Python, like R. You need sort of open data science tools for it. So we created three things all at the same time. We created PyData, the community conferences and sort of that the community. And then we created the company, Anaconda. And we created a nonprofit called NumFocus to be a fiscal sponsor for a lot of the projects that were in the scientific and numerical computing ecosystem. And so that was 13 years ago. And since then, we've worked on a number of projects at Anaconda. We don't tend to brand everything like Anaconda blah. So all of these projects have their own names, which is sort of one of the reasons that people sometimes don't realize how many different things we kind of have made or have worked on. But Jupyter Lab, for instance, was actually incubated at Anaconda. We're currently maintaining Jupyter Notebooks, so Notebook Classic releases. We're funding the work of Beware, for those of you who are trying to do mobile development in Python. There's certain things about Python, WebAssembly, that we've been building around PyScript and a number of the related technologies there. So there's a lot of different things that we've worked on over the years that we've supported or that we've built. And it's been a lot. It's been a lot of fun. But this doesn't really answer the question of why, right? So Travis and I were obviously big fans of Python, but why, ultimately, why couldn't it have been Perl or Ruby or something else? And Python has this really interesting characteristic that we came to realize, which is that it was a tool that could be used by many different kinds of people, many different kinds of job functions at a business, many different kinds of personas could all adopt Python. So on the one side, you've got traditional software engineers, programmers. They can program a lot of other languages. They can pick up Python, and it's not horrible. Like if you're a C++ nerd, or if you're a Java nerd, you might turn your nose up at Python, but it's better than coding MATLAB, right, or Fortran. So, on the other side, for the Excel people, you would never consider using C++ or debugging some, obscure thing in Perl, but you could pick up Python. You can read Python and sort of cut and paste and learn by example. So it's palatable to both ends of the spectrum, but of course the real sweet spot are the people in the middle, the people that at the time we were calling them analysts or data developers, scientists, quants, you name it, all the people in the middle who need to write code to get their work done, but they don't get paid for code. They get paid for the insights from that code. They get paid for the models that the code represents, right? So the fact that Python could play in all these different roles and that it was one language that did all of these roles, that was a really, really very powerful, special thing about Python. But that still doesn't, there's one other aspect of Python that that Travis and I sort of came to understand, which is that Python isn't just another language in that it was used by people who did not think of themselves as programmers. It was used by people who are in the product marketing group. It's used by people who are just learning, people who want to tinker with robotics, people who were trying to make and script really beautiful, like artistic things. They would learn a little bit of Python or maybe some processing JS. So the interesting thing about Python was that it was this very broad and democratized approach to computing. And I have a screenshot, sort of a picture here of a book by a guy named Ken Iverson who created the APL programming language. And he had this wonderful saying that notation is a tool of thought. This was his Turing Award acceptance speech. Notation is a tool of thought. And of course, I don't write APL, and I don't particularly think any of you want to go and learn APL. But the concept is still there, which is that it's not about just another language. It's that language is not only how we communicate with each other, but how we think internally ourselves. So when you teach people to think computationally, to think about data, to think about processing, data processing in computers, the language you can teach them to do that in, that now becomes thoughtware, not just software. So the idea that Python has a pedigree as a teaching language, if you want to learn about the origins of Python, there's a wonderful documentary about the Python programming language that will be coming out later this year. And I appear in it for a little bit, but that documentary captures the beginning of it and talks about how Guido was trying to make a language so that every person could learn how to program. It was a project called Computer Programming for Everyone. Really interesting project, and Python bears some of that pedigree in it, which is, it's no surprise, it's not an accident that Python is such a popular teaching language. So anyways, these were the motivations that we had. This is a realization we had later on about how important it is to make computing accessible to everyone. By doing this, by using a language like this, we were then able to reach people like scientists and engineers and geneticists and astrophysicists and people who would not think of themselves as software developers. They did not take very many computer science courses. But they could take up Python, they could wrap some C++ or Fortran code, they could go and start doing really interesting things and building tools. So we started with this vision of trying to make Python a tool for data analysis for the world. Big data was all the rage for a while, and then actually at one point, our tools for doing data analysis started exceeding the popularity of some of the technologies for data storage and data transformation, and that was really cool to see. Jake Vanderplas, one of the maintainers of scikit-learn, had this wonderful, an astronomer actually. He had this nice little slide that I'm stealing that talks about the different eras of Python. So it started off as a scripting language alternative to Bash. And then in the 2000s, that's when I started getting involved. It was very much the SciPy, the early scientific Python movement, where it was an alternative to MATLAB, and Fortran. And then in 2010, that was the PyData era. And that's when we really pushed and really drove the adoption of Python as an alternative to any number of data analysis tools, including R. There are a lot of people who like Python more than R. R continues to be a thriving and popular language, so I don't want to create there was a lot of people trying to push us to have language wars with the R people in the early 2010s, and I don't think either party was particularly interested in doing that, but I think everyone likes to have a fight, so anyway. So that's kind of the evolution of PyData and why we put it in place, and my observations on some of the reasons why it was such a unique and powerful thing. So let's talk for a minute about then this topic of open source and open source software and software communities and why that matters, or what we've learned about that given how Python has grown in popularity. And I'm going to start with a pretty heavy slide. I think it's maybe the only time capitalism has appeared on a slide so far at this conference. But I think it's really, really important for people to understand that the world we live in, the modern world, and how we think about software, how we think about how all of this stuff works, it's very new. It's actually really new. So software as a piece of intellectual property in America, that was established in the Copyright Act of 1976. And it went into effect, I think, in 1978 or something like that. But the point is, this is a fairly new thing. I know the 70s were a long time ago, but the ability to treat software as something you could even copyright is a new thing in the world in the last 50 years. Now, the important thing about this is that we're inventing a concept of property. They're creating a completely, in this act, they've made software into something that is property, that you can copyright, you can sell, you can assign, you can move around and distribute. And that's okay. You might be like, okay, Peter, why are you telling us this? Why does this matter, right? Well, the interesting thing about property is that when we think about normal property, like a car or a backpack or a laptop or a house or whatever, an airplane, these are all things which they're limited, they're physical, they're scarce. But the interesting thing about software is that with the rise, about the same time, the open source and the free software movement started as well. And the growth and the evolution of that movement, or that way of doing software collaboration, it proved a really interesting principle. It proved that software could be viewed as unproperty. And you might wonder, well, what the heck is unproperty? There's stuff that's kind of free and available, like air or water, and even those, there can be limitations on how much we can use of those. But unproperty, what does that mean? Well, if you think about it, there is nothing in the world that is anti-rivalrous, that you physically can deal with. right? So if we have an apple tree, and if I pick an apple off the tree, there's one less apple on the tree. If I eat the apple, there's one less piece of the apple available for everyone else to eat. There's no apple in the world where if I take a bite of it, an extra apple appears for me to give to you. Or if I make a soup and I give you a bowl of soup and you drink the soup, all of a sudden my soup gets more delicious, right? That'd be amazing if you have that bowl of gazpacho or something where the more people drinking it, the more delicious it gets. But that's exactly what open source software is. The more people collaborating together on a piece of software, the more powerful it becomes. The more use cases, the more bugs get found, the more interesting things happen around it, the more people build on top of it. So software, when we get together and we don't treat software as a scarce and physically limited rivalrous object, but we treat it as unproperty, we treat it as a mode of collaboration, all of a sudden we unlock this entirely different kind of mode of economic, well, not even economic production, but just a different mode of dealing with this. And you know, with open source projects, those of you who are, how many people here are maintainers of open source projects? Anyone? Yeah, a few, right? You know, if someone forks your project, that's a fairly unfriendly thing, right? Because you'd rather them talk to you and say, well, here's what we like. Should I build a plugin interface? Should I build an API here so you can leverage it? But if someone forks your project, I mean, they can do it if you put the open source license on it. They can do whatever they want. But that's seen as somehow destroying some value, right? Because now they're going to have users and maintainers that are going to use their fork and not your thing, and now you guys are sort of wasting effort, right? So this idea that sharing increases value and forking actually decreases value. That's unlike any physical object in the world. So when we think about software, and those of you who use, who maintain, who participate in open source software communities, you have this intrinsic understanding of an abundance mentality as opposed to a zero-sum or a scarcity mentality when it comes to physical goods in the world. And that leads me to this other observation that I had during the last 25 years I've been doing this, which is that these open source communities then are extremely unique human ecologies. And I don't know if the word human ecology has turned up in anyone else's slides, but I'm getting right into all this philosophy. Hope you enjoy it. But the interesting thing about this is that it's a very different mode of doing software development. Now, we can get paid to write software. I can get paid to write software. Many of you probably get paid to write software. But when you go and you work on a piece of open source code and you work on a project that's a community project and you're contributing to it, that's a very different kind of thing you're doing. You're contributing and you're participating in a collaboration community, and you and your collaborators have a different set of shared values than you and your boss or you and your company, right? Because with your company, you have a transactional relationship. You're putting in intellectual effort, you may be producing certain artifacts, they're paying you for it, the transaction clears, everyone's happy, everything's great. But when you are going and working on a code base and you're chasing down a bug in some piece of software that you and others are building in an open source mode, that's a different way. You're not going to go and ask your other maintainers to pay you for the 3 hours you spent last night debugging something, right? Or how much time is spent to build the standard of the build system. That's not how that works, right? So when you think about how we manage these communities, and I'm sure people here have run into maintainer drama, or you may run into egos and all sorts of human collaboration challenges. Those are natural, but those are still done. They're part of this community. They're part of this very different kind of approach to human ecology. So the trust that we build when we're engaging with each other on these kinds of shared values are very different than well, I guess we would call it trust, but the relationship that we have with a transactional employer that pays us for, a chunk of software that we wrote or delivering on a milestone or something like this. And I think when I had this realization, gosh, many, many years ago, I started looking around and I realized that a lot of people have this wrong. A lot of people don't just think about open source communities wrong, but they're thinking about software wrong, in that both venture capitalists and a lot of my open source developer friends are all thinking about the code as being the really important thing. But the code isn't the important thing. Actually, just a tarball of some source code is kind of useless, right? The actual software is, metaphysically speaking, not just an object. It is a dynamic relationship. And so if you look at a project and it says, oh, well, here are 5 people maintaining this project, and they're cutting releases at this rate, and here's what the tracker looks like. And this project, we'll say it's alive. And sometimes we'll look at a project and say it's abandoned, it's dead. Well, does that mean the code doesn't work anymore? No, the code probably works fine, right? The code probably can work for a very long time without any bugs. But we say that particular project is dead or alive on the basis of the liveness of the collaboration in it. And the difference in this mentality is the difference between viewing a river and viewing simply a scoop of water out of the river. So the code at any given point in time, any snapshot, any tarball, any release, it is a scoop of water out of this river. And yes, ultimately, you need to use that water. So you still have to scoop the water, you have to cut the release, you have to install the code and use it. But that's not the part that's living. The living thing, the thing that is alive, is actually the river itself, right? Which is more than just the water in it. It is actually the shape of gravity and the rainfall and all these other things that make a river what it is. And likewise, when we look at what a software project is, it is a dynamic, almost like an intellectual dance between many people agreeing to show up in a particular way and collaborating on something together. So I had this interesting variant. How many of you know what Conway's law is? Show of hands, or heard of it? So Conway's law is this really wonderful, wonderful concept. And it came from, decades ago. This is a management consultant or someone who was researching how software gets built. And he made the observation that software systems, the architecture of software systems, tend to resemble the communications architecture of the teams that built it. So if you hire 3 different consulting groups to build some kind of information system, guess what? The architecture of the information system will have 3 components. If you have 5 different teams, then you'll have 5 components. And so something simple like that, okay? Very, very simple concept, but you can see ultimately what it's reflecting is this deep intuition that ultimately software is the artifact of human collaboration and the patterns of management, power, responsibility, communications, all of those things, those between the humans, that reflects itself in the software. And there's a logical conclusion, or maybe an extension of this, a corollary, I suppose, which is that code is a cultural artifact. Code is a cultural artifact. So open source isn't just about licenses, it's about how the nature of the collaboration and what it can give rise to, the way the code is structured. And this is a really, this is all very abstract and philosophical, and I apologize for how sort of philosophical meandering this is, but this is really important because the way that the PyData community emerged, the way the SciPy community emerged, the structure of all the packages, all these tools and all these libraries, they are actually a living version, a living manifestation of Conway's law. That the community of people, there were applied physicists, and there were engineers, and there were astronomers, and there was all these different kinds of people who were banging around in this ecosystem, and they all collaborated to build a interlocking, connected set of tools. And yeah, sometimes, some tools didn't work with each other, and other times people decided they didn't like one thing and they built a different thing. But for the most part, each of these people had something better to do, something they were responsible for that wasn't just writing code. And so they had a natural inclination to scope things down and get them working, and then put them out there and have other people reuse their pieces. And this kind of humble scoping sort of approach in this human ecology of these people in the SciPy ecosystem, this led to then a software collection of tools that were quite powerful, very good and specialized at what they did, and they had really nice interconnections with each other. So the fact that we got Legos sort of magically happening, this cellular approach to the software architecture, it's very different than if you go and you buy a MATLAB license, which of course has toolboxes and things like that, but it's one dev team, building tools a particular way. So, by the way, as an aside, the reason why all these people had to build their own tools, I laugh about this a little bit, but we think about classical open source, whether it's Emacs and VI or Linux or the Apache web server, things like this. There were a lot of what I would call software nerds and software devs in the 80s and 90s. They were writing things to scratch their own itch. That's the origins of open source software, scratching your own itch. But then the scientific Python community, people had to scratch their own itches because the CS people did not know enough differential equations, did not care enough about numerical computing to reach those hard to scratch spots, right? And without going into too much of an aside, there is absolutely a very, very big difference between traditional applications and then numerical applications, but we're running a little short on time, so I'm not going to go too much into this. But anyway, the upshot of all of this is that, in my estimation, what made the SciPy and the PyData community so great, made those tools so great, was the community of people who made it, right? That there are many key individuals, very amazing people, wonderful, wonderful people, but almost to to a person, like each one of these people that I've met and I've known for now well over a decade, almost 2 decades, man, they're all really, really genuinely good people. So Fernando Perez, the creator of IPython and Jupyter, he is a hometown local from Medellin, right? So I texted him, like, Fernando, I'm in your town. And he's like, gave me like a long list of like restaurant recommendations and food and all this stuff. This kind of spirit, this kind of like, they're just all very, very good people that were collaborative. And out of that collaboration, out of that human ecology, we got these tools that now everyone uses that are ubiquitous, right? It's how the world does data. It's how the world does ML and AI. So that community ethos and the values those people had, that was just foundational to how we got this done. So if we reflect on this term open source software community, I'm gonna break it down word by word, right? So open is a value. It's a value regarding how we treat contributions and how we value user freedom. That we put this out there, people can use it, right? That is sort of grounded with original free software and open source kinds of concepts. But source, now if we think of source, that's actually becoming a bit of an outdated term. If we think about it, back in the day, the ability to read source code was enough to give a user these freedoms. I don't know how many of you are familiar with what are called the 4 freedoms of open source. But the idea you can use it, you can study it, you can modify it. All of that was based on the idea that you could read the source code. Now things are so complex. Many things are tied to closed and proprietary APIs that just reading the source code doesn't really matter so much. Like do you really have those 4 freedoms? Or even additional freedoms that you might want? It's kind of a toss-up, right? So that particular concept is maybe insufficient for defending the values that created these communities in the first place. And then software, I sort of did this just a few slides, and I know it's quite philosophical, but I would challenge you all to think about software as something that can come from different, or can be viewed from different value systems. Viewed from the value system of businesses and economic exchange, it's an artifact of intellectual property that I pay some knowledge worker for to produce, to check into a repo, and now that's what it is. But from the perspective of a collaboration open source community, software is it's the value. It's something that people do together out of a set of shared values. And hitting a particular release date, yes, I mean people get stressed about that in open source projects. But the goal is to make a high quality piece of software. It's ready when it's ready. These kinds of concepts. That comes from that open source community ethos. And lastly, the community, right? And I won't say too much about it. I think everyone understands what community is. But in my definition or use of it, I very, very precisely mean that it is a social environment where we can live our values. Not just random people we find ourselves drinking beer with, right? It's random people we like to drink beer with, right? People that you actually share real values with. Okay, so that was a bunch of philosophy about open source software. Hopefully you found it a little bit interesting, maybe different than how you're used to thinking about these things. But this is all very, very important, right? Because we are now right in the middle of the AI revolution / hype cycle / God knows what. So let's talk about AI for a second. From my perspective, the last 50 years of tech have been about 2 foundational and fundamental scarcities. One of those is bandwidth scarcity, and one of them is knowledge scarcity around how to make software. It's kind of a weird thing to say, but the internet, if you think about when the internet came along, right, you had very high latency compared to the amount of information that was out there. So we had bandwidth scarcity, and then with the PCs, everyone could have a thing on their desks that could do millions of calculations every second, but nobody could write code. So the knowledge of how to write code was fundamentally scarce. And that's been the condition we've all lived in. That's what gets us, many of us, our jobs, is because we know how to do this, right? But that's changing. And I want you to think about a question before I sort of show you an answer. Think about how many people you know do IT or are in the technical field. That means they can write code, they can plug in a server, or they can rack a server, they can maybe write a SQL query, they can generate some Excel dashboard. Anyone in the IT, remotely in the IT area at all. So when I did some digging around into this, the number I came up with was that this constitutes about 4% of the world's population. 4% only. Coders, network admins, sysadmins, DevOps, whatever, anyone remotely technical. And the, I think, total value of that industry is many, many $1 trillion. I guess we have the market caps of some of the American companies themselves multiple trillions of dollars. But in terms of an annual sort of, from a GDP sort of perspective, somewhere it's in the ballpark of 5 trillion plus. But that is 4% of the world's population. So imagine a room, 100 people, and only 2 of them know how to do this intensely technical thing, right? Sorry, 4%, 4 of them. Keeping you awake, 4 of them out of a room of 100. It's been a long week for me. So what LLMs allow us to do is they allow us to turn on this technical capability for the other 8 billion people in the world. Assuming they actually work and stop hallucinating, okay? That's a little asterisk on the side. But if these things actually pan out, if we can actually use these tools to educate and empower people about how computers work, right? I mean, how many of you had to do tech support for your parents or for friends who don't know how to do computers? The printer doesn't work, yeah, this, that, and the other, configuring this thing. You all know how to do that, but you're the 4 people out of 100 in the room. And of course you get frustrated. You're like, oh, this website, this cookie, that thing, this thing. Okay, no, you shift click this and download that. No, don't download the image, download the PDF. Like all of these things that we think about that are just natural for us because we're software people, right? That is completely alien gibberish to 96% of the world. So if you can actually empower them, what does that turn on for them? Think about just 150, 200 years ago, the world mostly was not literate. Most people did not know very much math, and certainly many people could not read or write. And over the course of the 20th century, many, many countries, most countries, through explicit education and investment, have gotten their populations to be literate. Well, we live in a very technical world, and it's been somewhat acceptable so far that only a small percentage of people know how to deal with that technology, but it certainly leads to many problems, right? People get their identity stolen, there's all sorts of scams and crime, there's all sorts of misinformation, disinformation, because people don't understand how to think about computers and information. So the ability for us to go and empower that other 8 billion people is absolutely massive. It's an unbelievable opportunity. And the interesting thing about it is, rather than us as software people and technologists and IT people making lots of little components that can then be pulled together and plucked together to make something, we can also, like with maybe next generation AI technologies, we can sort of 3D print entire solutions. And that's a really, really amazing and interesting thing, right? So we're really kind of going through a period now where we're going to unwind the entire technology architecture stack. And it's not today, but it'll be over the next few years. We're going to unwind a lot of the stack. We're going to really change up all these architectures and really think about what are the pieces that we need in order to allow these AI technologies, not just LLMs, but whatever future models might come, allow those to plug many, many people's needs directly into these information system 3D printers. I had just a few months after ChatGPT's release, I was just kind of playing with it. And this is the original ChatGPT, right? This is in December of 22, just a few months after its release. I was playing with it and asking it all these questions about physics, and it was actually pretty good. I was thinking to myself, like, wow, if I had this when I was an undergrad in college, I would have done much better in physics. I would have done much, much better, no question. And I sort of called this like a Wright flyer. So this is the first airplane, a Kitty Hawk. I call it sort of the Wright flyer moment for AI. So it was not a very good airplane, but it was an airplane. It flew, right? So then, of course, you can ask ChatGPT to count the R's in strawberry, which it can now do. But the fact that that was hard is kind of causes you to be like, wait, what's going on here? And so maybe instead of airplanes, what we really have is like Zeppelins. So we're in the Zeppelin era. We're not quite at the airplane era, but we're getting there, right? We're getting better at propellers and ailerons. And it's not just me saying this. Many, many people in the world have this conviction, which is why they're plopping hundreds and hundreds of millions of dollars into training these models. It is just kind of ridiculous the way that this is completely blown up. And I don't know about any of you, but the way when I read these kinds of things, I look at this, it's both exciting and also terrifying, because if these kinds of technologies are so expensive to build and only a few people can do it, where does that leave the rest of us? Where does it leave the rest of us? I mean, Sam Altman's going to go and build some $500 billion project, maybe. But like, I can't build a $500 billion project. I don't know how many of you here can. But what does that do for the rest of us? And he's not going to do it out of charity, right? Like, I know OpenAI is technically a nonprofit, but I'm pretty sure he wants to make that $500 billion back, right? So what does that mean for us? And if you follow Twitter much or you follow some of this conversation coming out of Silicon Valley, there's this very strong orientation towards what they call the great man sort of theory. Like in history, there's these single people who shift, the course of history, sometimes in a good way, oftentimes in a not good way, but that great man theory and that whole like man of the arena, and it's so intense, and it's like this very, I don't know, there's a sort of this heroic narrative around this, which is very sexy, very fun, really cool, gets you kind of excited, feels like you're watching a movie, hero's journey. But when you look at how innovation actually diffuses through the world, and if you look at the durable and good and sustainable innovations that have really changed the world, it's not just that. It's not just one person with some genius idea. There's always a process, and there's always the diffusion of innovation is actually a really interesting process, a fascinating thing to read about if you have an interest in it. But what we've seen, what I've lived in the open source community, is that when you have a collection of collaborators, human collaborators, you build a much more parallelized, much more durable kind of innovation surface. And you explore the art of the possible in a much, I would say actually even more cost-efficient way than just saying, well, here's our guy, here's our gladiator, he's gonna solve it, right? And when you look at the reality, yeah, modern AI, for all of the hype and all the noise about all this stuff, actually it's all built on open source foundations. A lot of it is built on stuff that has been built by teams of hundreds or thousands of people laying foundational work. But nobody's writing, billion-dollar checks to those people. No one's writing articles in Forbes or VentureBeat about these people, because the way the news media and everything works, they're looking for the new. They're looking for, the next thing. And that just is not very sexy to say, well, here's a pile of open source maintainers chugging away at code. That's not that sexy of a story. I think it's very interesting, but, I don't write for VentureBeat. Anyway, but I'm here to say that I really fundamentally believe that AI innovation can be democratized. I don't think it has to be just a single person with $100 billion in a war chest. When we look at what is coming, what is almost certainly coming, we know that models will be composed, and that networks of models and composed models and smaller models connected to in situ sensor processing, these kinds of things are going to give us vastly better prediction. They're going to be vastly more performance reasonable as well. And when you do this kind of thing, you have the opportunity for a large crowdsourced approach to pulling data together and data sets for both evaluations as well as for training. So all of these things, actually I have a list here of many different kinds of really cool things that are, I consider them sort of really exciting because they all point to this idea that we're probably 100x away from efficiency of what we can do. Now that might be kind of rich to say because there are many people who are betting lots of money that they have a very deep moat. And I'm sitting here betting that no, this stuff is gonna get a lot cheaper, right? And so we'll just see who's right. But I think there's a lot of things, a lot of evidence to suggest that our current approach to transformers, the current approach to attention, what we're doing with these things is completely too expensive for the actual amount of lift we're getting on the back end of it. I think a metaphor I made for someone just on a call a couple of weeks ago was the fact that these models are all sitting behind APIs, it helps maintain the illusion. Because when you sit here and you just say, okay, here's my API token, and here's the thing, boom, boom, now it's like ripping out tokens, tens of or hundreds of tokens per second. It feels great. What you don't hear is the loud whirring of fans on a data center somewhere, 1,000 miles away. But every time you generate an image, it makes it a little more efficient now, but I think the statistics used to be that with DALL-E at least, every image basically was a full cell phone charge. And so that just gives you a sense of how much energy is involved. And the metaphor I used for someone on this call was, imagine if you're in a car and you're like, wow, this car is really powerful. And you hit the accelerator, you hit the accelerator, just boom, and it goes. And the sales guy's next to you is like, yeah, this car's awesome. And then you're like, but hey, there's this like long pipe hanging out the back. And just don't worry about the pipe. And like, why is it connected to this locomotive over here on the train tracks next to the car? Don't worry about that, right? The car feels really good. And so with AI right now, the way that so many people consume it through APIs, if you're not running local models, if you're not hearing your dual 4090s like spinning and whirring, if you're not watching those tokens painfully come across like this, you're not really experiencing actually the energy cost and actually how deeply inefficient the current architectures are for what we get out of them. It's amazing they work at all. It is amazing that I can dot product some vectors together and get Shakespeare coming out of it. I admit that's completely amazing and mind-blowing, but the point is, I think there is much more improvement we can make on this stuff. And to get deeper into just a few of these. I know I want to be sensitive to time, but one of the really, really important things about this is that all of these really, really big foundation models, as they get bigger, as they consume more and more data, the reason why people are moving to synthetic data sets is because they're out of human-generated data. They're just out of it. They've pirated all they can pirate, they've scraped all they can scrape, they're trying to buy up all these data sets. They're kind of out of human-generated tokens, and so what are they going to do? But the thing is, once you consume all these tokens, it doesn't matter if you're Gemini or if you're GPT or if you're Llama, when you start throwing all of this data at it, then all these models start kind of approximating and being very, very similar to each other. And there's a wonderful paper that came out last year about the idea of universal encodings. The idea that basically once you put all this stuff in there, there's almost this Platonic representation. I think it was called actually the Platonic representation thesis. And that hypothesis was that essentially, when you put all these books together, they're all going to know about birds and trees and rain and bicycles, and they'll know about war, and they'll know about love. And it's all going to kind of be the same because that is the general background knowledge of humanity, right? And so they all start kind of converging to being the same model. And there's just this spring, another paper came out called the strong Platonic representation hypothesis. And what they did was showed in practice the reality of this. So they took a RAG embedding system, and they had an opaque set of weights for a RAG system that they didn't have access to the training materials for. They created a second embedding vector from data that they did have access to. Then they just computationally mapped, basically computed the rotations. And then by basically querying taking vectors and embeddings in the one RAG embedding space, they can actually do that transform and start pulling data out of the other one. They were able to recover PII, they were able to recover all sorts of stuff, basically pulling stuff out of the other model. So these things, although we sort of treat them as these magical black boxes, they are not black boxes, right? And so I would recommend taking a look at these papers if you're interested in how LLMs actually work and what we might be able to do with these. So just because these people are spending hundreds of millions of dollars to build these giant, really cool black boxes that they put behind APIs and plug into gigawatt power reactors. At the end of the day, these things are going to be interpretable. At the end of the day, we're going to be able to pull stuff out of them and see what's in there. And so there will, I think, be a democratization in our ability to play with this stuff. So I want to give the open source community and people who want to have a democratization aspect and want this stuff to be accessible, I want to give you all some hope, right? So if you put all this together, I fundamentally believe these models can not just get 100, but 1,000 times more efficient, especially for very targeted tasks. I think we're going to compose and mix them to build extremely high performance, not hallucinating sorts of approaches. And I think that basically, even though foundation models, the big headlining ones, get all the attention right now, they face a lot of legal and technical hurdles to get to the next level. And just to give you a little bit of motivation, on the left is basically, well, it's illegible, I mean, at this font size, but it's something like 80 or 100 lines of NumPy code, which is basically the transformer model. And on the right is your brain running on 20 watts, right? So these things run on, they train on unbelievable amounts of power. And over there is your brain running on, a fifth of a 100-watt light bulb. So we have a long ways to go. A long ways to go. And these pre-trained ones, transformers again, as a language model, they're great and amazing, but this is not the final word in any of this stuff. And who am I to say this? I'm just some rando here on stage, but there's this guy who also is saying the same thing, right? And he has some credibility in this space as well. So I think right now, for all those of you who are thinking about, well, okay, is AI going to kill us all? Is AI going to take away all the jobs? Is AI just a Western front to try to suck all the VC dollars away? What is it, right? I want to give you all basically hope through here that AI is an emerging thing. Right now, it's a lot of people, technologists, and whatnot in the, a lot of them in America trying to scam investors, I think, a little bit, but also trying to get real money from investors to build interesting things. That's going to churn a lot. But at the fundamental level, what these things are actually doing is quite magical, and I think it will get much, much better and much more accessible. So last thing then is, why does it matter that we make it accessible, right? Why does it really matter? And the reason is because of even more philosophical stuff, I apologize. But a very, very famous mathematician, computer scientist named Norbert Wiener, he worked on early days of computing, when computers were analog, anti-aircraft gun targeting systems, right? So he wrote this wonderful book called The Human Use of Human Beings. And he writes it in this particular way. He has this really wonderful line in there. He says that these kinds of, if we trust these prediction machines to autonomously make decisions, they are going to do things in a mindless way. They are not going to be in accord with human values. And there's that word values again. Very, very important, right? Here's another person, Jacques Ellul, who is a philosopher of technology and a critic of a lot of technological development in the mid-20th century. And this is a lot of text here, but he criticized capitalism, communism, socialism. He criticized all of it. It's all the same thing. All of these things, he says, are looking at industrial processes. They use technology and industrial processes as a way of essentially creating, subordinating the natural world, as a way of eliminating human values from consideration, and really elevating sort of this, what do you call it, the aims of collective economic production and efficiency. They were elevated almost to the point of religion in the West. Again, about values, right? And if you recall what I was saying earlier about how we think about software and open source people working together on software, it's not about the most efficient process. It's about us sharing values and or working on a collective technical project with shared values. That's different than when people are trying to maximize how many tokens per second they get so they can fire all of their developers and replace it with an LLM, right? Very different ways of looking at the world, ultimately rooted in values. And for a long time, I would say for a very, very long time, even in the software revolution of the last 30 years, 40 years, we have treated values as a separate topic from technology. We've kind of, I think, Google, the whole like do no evil kind of thing, or don't be evil, and like a lot of these things, like there was this concept that you could just build technology and it could be value neutral, and you wouldn't have to have these like sticky and gnarly and weird ethical, moral questions about values. But with these AI technologies, all of their applications are ways for us to impart our values in the world. And we cannot avoid those questions. We cannot avoid those questions. So this is something that's happening right now to the internet. This is a paper that came out recently, and maybe it's hard to read. I'll read it for you. Consent in Crisis, the Rapid Decline of the AI Data Commons. And it's tracking the fact that more and more places on the open web are closing up, putting in paywalls, putting in Cloudflare or other kinds of security checks to make sure you're not a crawler, blocking certain IPs, blocking certain kinds of activities. The open web, as we had built it, the internet, one of the greatest inventions of humanity, the internet is basically shutting itself down and fragmenting into pieces because all of these different sites and all the people who make the content and the long tail of people who are doing so much hard work, and they put up interesting reports, or they write certain things, they put them online to share with the world, all of these are getting strip mined, so they're all shutting down. And would Sam Altman look at this and say it's his problem? Would Elon Musk look at this and say it's his problem, or Mark Zuckerberg? I mean, they're going to spend billions of dollars making new kinds of models, but do they look at this problem, this destruction of the information commons and the internet as a network? Are they going to look at that and say that's their problem? I don't think they do. And so that's on us then to actually say this is a problem and we need to do something about it, right? And here's a different version of the same problem. On the, there's actually the thing called the dead internet theory, which some of you may have heard about, that it's just so many bots talking to bots. Online forums or other kinds of places, it's just bots talking to bots now. On the right, I don't know if you can really see this, but there was a recent thing that people discovered that people were hiding prompts inside their papers they were uploading to archive.org so that people using LLMs to try to review papers, the LLMs would be naturally prompted to review their papers in a positive way. This kind of AI slop, this is exactly the kind of thing that then is destroying what we had at one point in time. We'll still kind of have, but it's decaying, this information commons, right? And in fact, I can tell you exactly what some of the trillion-dollar CEOs think about it. Your data doesn't matter. So this was actually last year. There was an incredible interview on The Verge right after, I think it was the Llama 3 point something release, and they did an interview with Mark Zuckerberg. And the interviewer asked, well, what if people don't want their data in here? And he's like, well, the individual work of most users doesn't really matter anyway. Opt out all you want to, you don't really matter, right? Literally, when the push comes to shove, they demanded that we don't use their content, we just wouldn't use their content. It's not like that's going to change the outcome of stuff that much. How many of you understand or know what the central limit theorem is? right? This is him looking at you and saying he's going to deliver you a corpus of AI content that is regressed to the mean, and none of you really matter that much. Now, each one of us, I acknowledge, may not matter that much, but in aggregate, all of us are the whole thing. A wonderful quote that I read from Carlyle: "The merit of originality is not in novelty, but in sincerity." That's why all of us matter, because we are sincere and genuine human beings, living lives, having experiences, and we use language as a way to connect with other humans. We're not using language as a way to generate coal for the furnaces of the AI training dungeons, right? So that language is a technology that humanity has crafted over 100,000 years, and that language and that technology, that belongs to all of us, right? So there are things that we are doing, and there's people I'm working in collaboration with to try to do something about the commons. So the Creative Commons, they're the ones that have the CC licenses. They just last week or 2 weeks ago announced that they're introducing they have a call for proposal or call for comment on a new system that they call Signals, which is a way it's a new social contract. Note the wording here. It is a social contract. It is about what values do we want to agree upon when we are sharing information with other humans on the internet, right? And so it's a way for you to indicate when you go and release something, CC by NC or CC by SA or whatever, when you do that kind of thing, what do you actually, what obligations or what rights do people not have when they're going to train on your materials? The IETF, the Internet Engineering Task Force, they've started working on a similar kind of thing, a way for websites, a way for web services to automatically signal their AI preferences of what should be trained on, what should not be trained on. You can think of it as like a glorified robots.txt, but it's much richer, deeper than that, so it's almost inappropriate to call it that. And then I personally am working on a new kind of open source, called a license or contract system that would allow us to defend and preserve some aspect of the work that goes into creating information commons and creating a commons data set for training models. This is something I've been working on for the last couple of years, and really it's rooted in this idea that the existing licenses we have for software are not enough, because they're all still rooted in this concept of copyright. And what we have with LLMs and deep learning technology in general, not just LLMs, but any kind of neural network approach, we have the ability to extract ideas from expressions, and so we need a new way to express a social contract between people about those ideas embedded in the expressions. It's a very kind of nuanced and little legal thing, but it's a really, I think, a really foundational piece of the puzzle to establishing communities of practice and to establishing these kinds of generative communities around what AI could do for us. Something that's really interesting, too, that we've come to realize as we're doing this work and working on this kind of new licensing concept is that there are many different ways that having closed proprietary or legally nebulous scraped sort of models, negative ways that those models impact the world. They make it harder to do research because researchers don't know if they're legally exposed, if they have liability when they use these opaque data sets. There's global implications. By not revealing the kind of training data that goes into some of these models, even though they're open weights or they're freely available, when people are in cultures or in countries that are called low resource languages, so that means they don't have as much digitized corpus, they don't have as many tokens to train on, those languages are at an extreme disadvantage relative to the West. So when you train one of these models and then you put a translation on it, the output is not the same as if you were to train a high quality model on the native language with the native idioms and the expressions and the concepts. A famous and wonderful example, well, not wonderful, kind of terrible and dark example of this is when you use Western LLMs and you try to have them say things in languages that are closer to Latin, not English, but Latin languages like Spanish, which have gender in them. And the idea of having gendered words and having gendered expression in the language as a part of the language, as part of the poetry, part of the idioms, that then conflicts into certain things that the West is trying to do and trying to be very sensitive around gender topics, and the things just collide, right? And that's not for a bunch of engineers in Silicon Valley to decide, that's for each of the countries and the people of the countries and the cultures to decide for themselves. So in a sense, there's a horrible term, well, a very precise term that implies a very horrible thing that I've come to realize, which is that if we don't do something about this to create a foundational playing field for an AI commons in the world, we will essentially, by default, have a sort of cultural hegemony coming kind of backdoored through these LLMs. But if we do this right, I am still ultimately an optimist about this, if we do this right, I do think that AIs and LLMs could liberate many, many people, could deeply re-empower us to have control and sovereignty over our computing environments again. So anyway, that's the talk. Sorry I got kind of deep and dark there, but thank you all so much.